Hello. Today I'm going to walk you through the Vector Search and AI Assistance Solution Accelerator we created as part of the Build and Modernize AI Application Solutions for Microsoft. The source code for what you are about to see is available for you to download. You can use this to explore the concepts for building AI applications in Azure. You can also take this code to use as a starting point to build your own proof of concept. You can also use it to simply demo the application itself and see how it works. This solution is available at github.com/azure/buildmodernAIapps. This type of solution we're going to explore today is what we call a data copilot. Data copilot is somewhat of a broad term. In short, what it describes is the ability for users to ask natural language questions from large language models such as GPT with their own enterprise data to enrich the response. The data used here can be anything from text documents to images to transactional data in a database. The underlying pattern for this is called Retrieval Augmented Generation, or RAG pattern. The extra data sent to GPT, along with the user's question and even prior questions and responses, enriches GPT's ability to generate a response or completion to the user. RAG pattern, or Retrieval Augmented Generation, is essentially a fancy way of saying we're going to add some contextually relevant data to a user prompt to use in a generated response. For our solution, we're going to employ a different method of indexing and search called a vector search that is based upon something called embeddings. Before we go much further, it's important to explain what embeddings are. Embeddings are a method of representing words or data as vectors in a high-dimensional space. Vectors are mathematical entities that resemble arrows having both direction and length. In this context, highly dimensional means that the space has numerous dimensions beyond which we can perceive. Embeddings aim to assign similar words or data with similar vectors, while different words or data are assigned different vectors. This allows us to measure the relatedness or unrelatedness of words or data, even images. Embeddings are particularly valuable for AI models as they enable computers to comprehend and process the meaning and context of words or data. In fact, they are at the heart of AI models like GPT and how they decipher what you are asking and how to respond. To utilize embeddings, a sentence, paragraph, page of text, or even an image is transformed into an embedding vector. When a search query is conducted, or more specifically a vector search, the natural language text of that query is converted into its corresponding embedding representation. Then a search is performed among existing embedding vectors to find the most similar ones. This process resembles making a search query on a search engine, which provides multiple results that are closely related to the query. Semantic memory may not yield an exact match, but it will always provide a set of matches ranked based upon how similar the query is to other pieces. Azure OpenAI embeddings employ cosine similarity to calculate the similarity between documents and a query. Cosine similarity measures the cosine of the angle between two vectors projected in a multidimensional space. This approach is advantageous because even if two documents are far apart in terms of Euclidean distance due to their size, they may still exhibit a smaller angle between them, resulting in higher cosine similarity. The scenario our solution presents is one of a retailer that sells bikes and accessories. The data for this is adapted from the classic SQL Server AdventureWorks 2017 dataset. We use this dataset because it is simple to use and allows us to explain the key concepts for building this type of solution, so you can go do this for yourself using your own data. Let's take a look at the architecture diagram for our solution. On the left-hand side is our database. We are using Azure Cosmos DB for NoSQL. This stores all of the data for our solution, including the retail bike shop data for products, customers, and sales orders. It also critically stores all of the user prompts or questions from users and the completions or responses from OpenAI. We also have Azure Storage. This stores all of the files we use in the solution, most notably our system prompts as well as our return and shipping policies. In the middle is the service layer. This includes the containers for our web application and services. It also includes Azure OpenAI Service, which generates vectors on data and queries and generates the responses. Azure Cognitive Search indexes the vectorized and JSON data stored in Cosmos DB and provides both vector and semantic search capabilities on top of it. Although Azure Cognitive Search is technically a data service, we've included it here in the middle service layer because much of the orchestration with semantic kernel happens in this service layer. On the right is our Web UX, which is a simple chat application built as an ASP.NET Server application. Let me take you to the repository where this solution sits. To get started, you can go to our GitHub repository, github.com/azure/build-modern-ai-apps. Once there, you can scroll down and click to our Navigate to Vector and Search AI Assistant. This page also has other solutions, including a payment and transaction processing solution and medical claim scenarios. This page also includes links to the Intelligent Apps Workshop created by our Apps GBB team. There's a lot of great samples information for using semantic kernel for building Copilot applications here in Azure. Next, let's go ahead and we'll click on the Navigate to Vector and Search AI Assistant. This will take us to the GitHub repository where all the bits for this application sit. We'll scroll down here and you can see it's got some overview information that talks about the scenario itself, explains RAG pattern, goes into the solution experience, provides architecture diagram for the solution, overall general workflow for the solution, and then some key concepts in here as well. Near the bottom, you can find out how to get started in doing the deployment for this application, as well as how you can get going with a quick start to get you up and running in here. More information below on how you can set up the application to run locally on your machine here is included near the bottom of the README page here. And then finally, at the bottom is information on how to clean this up once you're all done running the solution. You can deploy this solution in 3 different ways. You can deploy from Cloud Shell if you are simply looking to set this up as a demo. You can also deploy this and run from a VM in Azure. Or you can do a standard deployment to deploy into Azure and run in debug on your local machine. By default, the script will create a new Azure OpenAI account and deploy 2 models, GPT-3.5 Turbo and Text ADA002 for completions and embeddings. If your organization already has deployed Azure OpenAI and you wish to utilize it, you can specify an existing account name and models as well. In this example, I'm providing an existing OpenAI account name and resource group where the account has been deployed. I'm also specifying existing deployed models, which I've called completions and embeddings. The names here should match what has been deployed for you already. The script will deploy the web application and service layer containers into Azure Container Apps. Optionally, you can deploy using AKS by just adding this flag at the end. In addition to deploying the services in Azure, the install script will also load and vectorize sample data and make the solution ready to use. Let's go into the Azure portal and explore the services. We're here in the Azure portal. We're here inside a resource group after we've deployed our solution here in Azure. Let's go through each of the services that gets deployed, and I'll show you a little bit about each of them. First, let's go to a separate tab here. I've already deployed my Azure OpenAI account in a separate resource group, so I'll just go and show you what we've created in here. We've got our Azure OpenAI account, and then I've gone into the deployments blade here, and you can see we've got one deployment named Completions that's using GPT-3.5 Turbo, and then another one we've called Embeddings for Text Embedding ADA002. Also note here that we have additional rate limits or capacity on each of these as well. It's important when you set this up that you include enough tokens to do the embeddings and the completions. By default, the install script will attempt to do about 100,000 tokens per minute for both of these, And this should be enough to run the installation and vectorize all of the data, as well as run the solution once it's all been deployed. Next, let's go into our other resource group where all the other services have been deployed. First, let's go into our Cosmos DB account. We'll click into Data Explorer here, and then we'll take a look, and we've got 4 containers within here. We've got our product container. This is our product catalog for all of the bike information for our Cosmic Works bike store. And then we also have a customer container in here. This includes both customer records as well as all of their sales orders for each of the customers within our solution. We also have a completions container here. This includes all of the user prompts, all of the sessions, and all of the completions for the conversations that happen within our application. So here you can see we've got a session type record in here, so it's going to have a property called session. There's a session ID, number of tokens. You can see the name of the session here is called bike types. If I click through a few others here, you can see we've got a message here. This is a user prompt. You can see its sender here is by the user, and it's a type of message. You can also see the user prompt itself. What type of bikes do you have? There's also a rating on here. I'll show you this a little bit later in the user experience. And we've also saved the vector for the user prompt as well. Some other things you've got in here is we've got a assistant. This is a response. This is also of a message type. And here you can see this is the response. We have both mountain bikes and road bikes. Okay. The last container in here I want to show you is our leases container. And this is used because we employ our change feed processor within the solution. When a new piece of data is written to our customer container or our product container, change feed gets triggered, and then that generates new vector on the data and then inserts it directly into Azure Cognitive Search. We'll go through that and step through that code a little bit later in this video. Okay, next let's go to Cognitive Search, and we'll click on the indexes within here. And here you can see we have one index just called vector index in here. And you can see we've got about 1,800 documents loaded up in here, taking about 47 megabytes worth of space. We can go and see some of our data within here. We'll just go ahead and do a quick search. And you can see here is some data that's coming back in here. We've got bike category or bike products that are coming in here. And also the vector for all of that data. So we're storing not only the product data in here, but also the vectors for it. And then we also store all of the sales order and customer data within here. So all of the data within this solution gets vectorized, and then all of it gets ingested into Cognitive Search here and is made available for users to go and run their vector queries on. Some other things I'll show you in here as well. We can go into the fields within here, and you can see that most of these are marked as retrievable. Also, we have other fields in here that are marked as filterable or searchable within here. You can scroll down a few other things here. You can see the password information, the hash, and the salt. We do not make that retrievable within here. And then here at the vector property here at the end, you can see this is also searchable. And then it also has a dimension property of 1536. Next, let's go into our storage account. And there's 3 different containers in here I want to show you within here. We have a system prompts set of folders within here. We also have product policy, and then the last one is memory source. Let's go in and we'll take a look at the system prompts within here. And there are 2 types. We've got our retail assistant system prompt and our summarizer. Let's go ahead and take a quick look at this one here. And then this is just a text file, and this is used by Semantic Kernel and by our application itself. And the system prompt helps drive the behavior for our retail intelligent agent. And here you can see it just says you're an intelligent agent for the Cosmic Works Bikes company. You provide helpful answers. You answer questions about products and categories and customers and sales orders. Data will be provided in a JSON format. Some additional instructions here on just answering questions you're only provided information on. Don't reference stuff you don't know about. And if you're unsure, just say I don't know or I'm not sure. So these are all the types of things like a system prompt you would need to have for these types of applications. And so this is our example for the system prompt, and then I'll go into another one we have in here. This is our summarizer prompt, and I'll show you this. And here you can see this has a little header here, begin content to summarize, and then an input within here, and then end content to summarize. And then a description of what it is you're supposed to do, which is take this content we're going to give you and summarize it, keep it in plain text, just exactly 2 words, where we're going to use it, make sure no markup, no tags on there. So this defines what you would see as a summarizer prompt. And again, the idea with the system prompts is to define the behavior for the completion from Azure OpenAI. Next, I want to show you product policy we have in here. So we've got 2 policies. These are just defined as text files again. We have a return policy here, and this provides just information on returns for users. So if customers ask a question about how do I return something I purchased, the Azure OpenAI completion API will then use this data to help formulate a response for the user. Same with the shipping policies in here as well. We'll go ahead and take a quick look at that. And this provides all the information necessary to provide with OpenAI the information they're going to need if they get asked about any kind of shipping questions from users. Last thing I want to show in here is this memory configuration from the memory source here. And we have 2 types, and I'll show you this one here. What this does is this defines a series of faceted queries that we've got in cognitive search. And here we're just doing a very simple query in here to count up how many products are in each of the product categories within Azure Cognitive Search. And we store these in what is called volatile memory within semantic kernel. And the reason we're doing this is just to provide an example of how you can use volatile memory for something like this if you want to have something like a runtime aggregate or an updated count of something like how many products you have, or it could be number of items in a cart. It could be literally anything where you don't need to persist that data over a long period of time, but you just want to make it available for the application when customers or users are asking questions about it, or if it otherwise needs to be used within the context of your application. So we'll show you that source code and how that gets generated or used by the application at runtime when we go through and step through our app. Okay, last is I want to show is the containers in here, and we have 2 containers for our application. We have a web front-end application here, and so that's just called Chat Web ACA right in here, and you can go and see we have a container in here and just a few environment variables in here as well. And then the other one I want to show you, this is the main one. This is our web API endpoint, and this includes all of the service layer for our entire application. And so if I click on environment variables here, you will see there are a huge number of environment variables that are defined and injected into this container at deploy time or at runtime within here. So you can see we've got things like endpoints and keys for cognitive search, deployment model names, max tokens, chat completion names here, short summary prompt name here, all kinds of configuration values for our prompt optimization. I will show you that. The application goes into extensive detail on how to optimize the prompts that we use for Azure OpenAI, and this is something you'll want to take a closer look at. Other things, OpenAI endpoints and keys. So all the secrets and all the other configuration value that the application will need to be able to go and run. Okay, so that is it for all the deployed services we have in here. There's some other stuff as well. Of course, we've got container registry in here, container apps environment, VNet and Subnet NSG, log analytics, application insights. So other stuff as well that's within there. The whole idea and the point behind all this is we want to be able to show you kind of end-to-end how all of these services are composed and used together to go and build these types of RAG pattern applications that we've got for you here in the Solution Accelerator. Before we get into the application, I want to introduce something called Semantic Kernel. Semantic Kernel is an open source SDK that acts as an AI orchestrator for building these types of Copilot applications. Semantic Kernel provides the glue to bring together AI models and data with a set of connectors or plugins and skills which you can use to instruct an AI model how to behave, like an AI assistant or even how to summarize text. The SDK provides an extensible framework that you can use to build AI applications and will be central to the work you do to build this type of application. There are others like it as well, such as LangChain, which I encourage you to explore. Semantic Kernel is available for both .NET and Python users. For our scenario here, we are going to combine data from files that include shipping and return policies with transactional data from our database. This is a key scenario we wish to highlight in helping you understand how to design and build applications that can provide near real-time AI capabilities to your own scenarios. Some key words and concepts you'll hear here include, first, connectors. In this solution, we are utilizing the Semantic Kernel connector for Azure OpenAI, which we use for generating embeddings as well as chat completions. There are also plugins. These used to be called connectors, but in version 1 they are now called plugins. In this solution, we'll be using a plugin for Azure Cognitive Search. Then there are two skills in this solution. First is our semantic memory skill. This is used to perform the vector search for our solution. Next is a summarize skill. This is used to summarize the text you see in the chat interface on the left-hand nav in the web application. Memories are the source for where data is stored, and we have two types. Long-term memories are what is stored in Azure Cognitive Search. Short-term memories are what are referred to as volatile memory in Semantic Kernel. As the name suggests, these memories do not persist. They are loaded into memory. In our solution here, we use these to store some aggregate data that can be used to generate completions for our user prompts. Specifically, we store the count of products per product category and a total count of all products in the product catalog. One thing I need to point out that at the time of this recording in November 2023, there were a number of changes to Semantic Kernel. Some of the things here mentioned may or may not exist when you watch this video. There are four key elements of the solution: generating vectors, searching vectors, generating chat completions, and storing conversations. Users ask natural language questions using the web-based chat user interface. These are user prompts. These prompts are then vectorized and used to search the vectorized data. The results are then sent along with some of the conversational history to Azure OpenAI to generate a response or a completion back to the user. All of the user prompts and completions are stored in a Cosmos DB container, along with a number of tokens consumed by each prompt and completion. Let's walk through how we do each of these. We'll first do a tour of the user experience here that users will see. Then we will dive into the source code for our solution, and finally we will start the debugger and walk through a user prompt from start to completion. We will also walk through the process for adding data in real time to the solution. Since the solution is built around a transactional workload, this is a key concept we want to demonstrate. Okay, we're here in our browser and we have our user interface up for our solution. Here's what it looks like when there are no chats started or in the solution at all. So we'll get started by creating a new chat. And we'll go ahead and click on New Chat here and then click down at the bottom. And let's start with a simple question. What kinds of products do you sell? And you can see here it says we sell a variety of products including accessories, bottles and cages, lights and pumps, clothing, socks and gloves, and components, brakes. Okay, let's ask some more questions. Let's ask it to give us more details on bikes. And here you can see it provided more information. They have bikes in 3 categories: mountain, bike, and touring. Information, they have total 97 bikes for sale, 32 in mountain, 43 in road bikes, 22 in touring. This is interesting because this took some of that information that we pointed out earlier with those faceted queries. This is the stuff that's coming out of volatile memory, and it combined it with information that came out of the database, or the vectorized data that also came out of cognitive search. So here you can see it has taken and combined the long-term memory or the semantic memory out of cognitive search with the short-term and volatile memory, where we added up bikes or products and categories here, and then all the different bikes, and then combine that all together for that. So let's see. Let's ask it more questions about bikes. Let's ask more about road bikes. So here it's got more information, 43 road bikes, what kind of data they've got, so product name, description, SKU, price, tags, different sizes from 38 to 48 inches, different models, more information here, so we can just keep diving in. So let's ask it to list let's ask for more information on our road bikes. And here it provided a lot more detail here. So it's going to provide kind of a formatted list, go through each of the products within here. So we've got and it's all organized kind of tabular. So you've got a product name, a SKU, the description, the price, and some tags in here. And it's done that for 8 products that we've got within here. So this is nice. We're getting more and more information, and we're having a conversation with our AI assistant within here as well. So let me point out some other things within our user experience here that users can see. You can see at the top here we've got tokens. These are the tokens for the user prompt that are sent in, and you can see we have 1,025 tokens. And then the number of tokens that are used in the response at 34. What I can say about that is the tokens here used on the user prompt include not only just the user question, but also all of the data that is provided by the vector query. So you're going to have a little bit of text here, and then a lot of data that's going to come back from the vector query. The user question or prompt here is vectorized and then used in that vector query, and then those data, those products or the items that come back are then all passed with the question to Azure OpenAI, and then it generates this response. Because it's just generating a little bit of text here, it doesn't require that many tokens. It's going to use more tokens to process all of the data you can see than it is in generating it. And you can see that data if you click on user prompt here. So we clicked on the user prompt let me go back up, for the resistant, or this is the response that came back in here. So here you can see a few different things. First, here is the system prompt that we showed you earlier that sits within Azure Storage. So this goes as part of every request when you send a question or a prompt to Azure OpenAI. Then next, here is all of the data that came back from the user query. So this is all of the stuff that comes back from the RAG pattern query, vector search in cognitive search there. And each of them has a payload that you can see. So you can click on this prompt and you can see all these different products. In some cases, we've been looking at the same stuff, so it may be the same data, but in either case, that's what it's going to show you there. Other stuff you can see in here is you can also like and dislike. We don't do anything necessarily with this like and dislike in here, but we want to point out, and we implemented this because this is something that you are going to want to implement at some point later after you go into production with these applications, is you're going to want a way to be able to look at answers or completions from Azure OpenAI that customers may have liked, and then be able to filter on those. And you may want to take and aggregate those from lots of different users. In fact, you may want to take and vectorize those questions and responses, and then do further downstream processing or vector searches on those to find prompts and responses that, or prompts at least, that are similar with very similar words, and then looking at the responses or the completions of those things and finding the ones that people like within there. And then using that maybe as a basis for helping to optimize the system prompts or even the data that you use within your vector queries or your vector database for your users. So this is all kind of part of a larger prompt engineering scenario that you're going to go through either during the design of your solution here, but certainly after you go into production, this is something you're going to want to look at to optimize for that. One other thing I wanted to point out here too is the session here was renamed. And this is utilizing the summary skill that I showed you earlier. So after you get past a couple of different prompts and completions, the application will then ask Azure OpenAI, can you summarize this conversation that we're having, and then use that for the name here. And you can see it's taken the user prompt and completion here for these two, and then rename that as product categories within there as well. So, so that's another skill I wanted to point out here, is that after a couple of these, it will rename the entire session for, well, based upon whatever is the topic for what's being talked about in here. Okay, one other scenario I want to show you is I want to show the experience when you add a new product to our database here. The scenario here is one of an intelligent retail AI assistant. And since this is a retail application, we want to show the impact of data in a real-time manner for this type of application. So what we'll do here is I'm going to start a new chat here, and we'll say, what kind of socks do you have? And it's got two types, racing socks and mountain bike socks. So let's ask it, can you list all of your socks? We want to get it to list out all the socks that they've got. And here you go. So we've got 4 different socks. You've got mountain bike, racing socks, 2 different types, large and medium. Okay. So what I want to demonstrate here is we are going to add a new product to our product category here, and then we'll come back and we'll ask this question again. So I have Postman here that I've set up, and I've configured this put here to call my endpoint, and I'm going to add a new sock, and this is going to be called Cosmic Racing Socks, medium size. Here is just a description for it. I've got some price and a tag in here. So we'll go ahead and then run this. So let's go ahead and send it. And we see a 200 OK in there. So let's go ahead and it's added that into the catalog. And it's vectorized it and stored it in Azure Cognitive Search. So this should be ready in near real time. In fact, it was ready in like less than a second. So let's ask this again. And here it came back with the same number of socks again. So let's try this in a new chat, because sometimes it will use the history of a previous chat. to provide the answer. So if we start with a new chat, we'll have brand new here. So here you can see we've got our socks, and here you can see Cosmic Racing socks right at the beginning. So this is using a very simple scenario with just adding a product to our catalog, but this could be anything. This could be inventory, this could be what's in your shopping cart, this could be browsing history, this could be anything literally that happens within an e-commerce scenario where you want your intelligent AI assistant to be able to act upon that information and provide up-to-date, to the second, to the microsecond or millisecond accurate information for your users. Okay, now let's explore the solution and the source code in Visual Studio. We'll see that we've got a number of projects within here. In our solution, we have a search project. This is our web front end. Here is a chat service web API project. And then two other projects. We have our service project here, and then semantic kernel here. So let's start with the web application project here. So our search project. And you can see this is just a regular Blazor server application. We have some Razor files within here. You can see we've got this is our left nav menu in here. These are the icons that you would see up at the top left within there. Just some stuff you can see in here, like being able to click. We've got session ID within here and session name. Here's the thing that shows how many tokens are used within there. The key page here is our chat pane. This is kind of the main section of our web application within here. We'll just scroll through a little bit of this here. You can see that this will go through each of the messages within the chat there. So it goes through whether it's an assistant or whether it's the user within there. Here you can see a button to submit the prompt within here, or you can just click enter within there. Below here, some of the code that you'll see within here. I'll just scroll down until we're looking for a single function in here. Here's how you rate a message. You can undo the rating within there. And then our function get chat completion async. This is where everything starts from the user within there. So this calls the chat manager, which is up in our web API, and then back into our service layer. But this is where it all starts. You have the session ID and the user prompt that gets sent back. Here you can see within that function there, if there's more than 2 messages within the chat, it also calls the summarizes chat async in here, and that also passes the session ID and then selects the messages within that chat to go and then get summarized from within there. So that's the web front end there. We won't spend any more time in there. This is a pretty simple project. We'll go and show, here's our web API project within here. Also not much to see in here. These are all the endpoints that we have defined within here. So you can just quickly see we've got all the mapping in here for our endpoints within here. And that all maps to our service layer within here. So we'll go ahead and take a look at this. We'll take a look at all of the services within here. Here you can see this is the chat service. The chat service is essentially kind of the entry point for everything within here. All of these functions map to something within our chat web service API within here. So everything comes in and out of here. In fact, the entry point for everything you see is in this function here, get chat completion async. And here you can see here is the same session ID and user prompt that we saw from the web front end here. And just some things to show here, like first thing we want to do when a new user prompt comes in is let's get all of the messages in our conversation there. And then we're going to go and call our RAG service and get the response using and pass in the user prompt and all the messages. We'll walk into this. This is where The bulk of everything within the service happens behind this function here. And when that comes back, it returns back a result object here. And what we want to do with that is we want to go and persist everything that comes back. And that includes the user prompt that was in there with all the tokens from that, the completion message as well, and then there are, of course, response tokens for that, and then also the completion prompt, which also gets inserted within there. And then once we have all of that information, we are going to send all of that, the message, the prompt message, the completion, and the completion prompt. And then we will call a function add prompt completion message async. And this is going to then insert all of that into our completion container in Cosmos DB and do that in a transaction. So we'll come back more to this later. Let me go and just show you a few other services within here. We have some services that were part of the implementation before we implemented semantic kernel. So we've called these out where we could and just said, look, this is just an example. This isn't used within the application itself. However, we thought it was important to leave these in here if users want to get started to build these applications and do not want to implement something like a semantic kernel or a LangChain for the orchestration within there. They can go and do this just using the services themselves. So here's an example with the cognitive search service. This was our first implementation when we first wrote our first version of this, but we don't call this now. The other one in here that's not used anymore either is the Azure OpenAI service within here. And you can see some things that if you called Azure OpenAI or implemented these applications that would look familiar. Like here is our system prompt that we have. This now gets read out of blob storage. Here's also the more complex one that we use actually in here about an intelligence system for Cosmic Works Bike Company. This first one here is just a very simple one that we started with. This is the one that we have in our application now. And then here is our summarize prompt, which is our first version of that as well within here. A little further below, you can see some of the functions that we implemented that are now handled by the semantic kernel service, including our get embeddings async. So that just takes in some dynamic input, string, whatever, it doesn't matter, and then calls the get embeddings async from the Azure OpenAI client, and then returns all of those along with the number of tokens that it consumed. The other one we have here as well is our get chat completion async. This is where the response is generated from Azure OpenAI, and here you can see we have a chat system message here. This is our system prompt retail assistant, and then all of the documents that get returned back from our vector query, and then also our user message as well. So this is the user prompt that gets sent in the question. And then we create a new chat completion options object within here, and then call the OpenAI client to go ahead and generate a completion on there. And we get the response from that, and then the number of tokens that were consumed from the prompt and the RAG payload, and then the number of tokens consumed to generate the completion. Last one is our summarize async. So a similar looking function. You have a system prompt that is using our summarize prompt that we defined above, and then of course the user prompt is all of the information that's passed in, or the conversation from the conversation, and then that is passed in and then summarized, calling the same get chat completion async, but of course with a different system prompt in there to then go ahead and return that two-word answer or summary for the conversation. Okay, next, let's go into our Cosmos DB service. So this service is used within here. And so I'll walk through some things in here. If you've used Cosmos DB, a lot of this should look very familiar. You're going to create a new client. You have serializer options. Within here, you're going to connect to containers in your database within here. We are also, as part of this, when we connect to Cosmos DB, we are going to start our change feed processor. And we use the change feed to handle any additions or updates to any of the transactional or operational data within our database. So we have a list of containers that we monitor within there, and that is the product and customer container within our solution, within our Cosmos account. And so Cosmos will monitor any changes to happen to those containers, and it defines a delegate, and this is our change feed handler function here. So if a new record or records or items get inserted or updated, this function gets called with any of the changes that are within there, and then it will iterate through each of them and then handle that depending on what we want to do. So within our function here, I can describe a few things that are happening. So first thing we want to do is we are going to call this model registry class that we have, and we are going to try to identify the type of object. So let me go into our model registry class here. And here what we have is a dictionary where we define different types of entities within our container. And what we do here is we are trying to define a list of type matching properties that we want to use for our search in Azure Cognitive Search, and then also naming properties that are defined within here as well. And these are used as part of what gets vectors generated on them when we insert new data within Cosmos. There is, of course, or can be, a lot of data that can get stored with JSON documents or with anything in a transactional database. Not all of it may be interesting. So we use the model registry class here to kind of help define what that is. Also within here, when we define that, we also then call our RAG service, and then we call this function called add memory. So I'll go ahead and go into the implementation for that there. And then what we do is we have another thing here that's called embedded entity. I'll go into what that is here within here. So here you have embedded entity. And what this does is that it controls how Azure Cognitive Search stores the data when it's inserted. So here you can see within this entity type, we have some different attributes. We obviously have kind of the float. This is the vector that we're going to store for our data. But we also have these attributes that says, on the searchable field, if it's filterable, and then we'll set that to true, and then is it facettable, and then we set that to true as well. And then we have for the embedding field, the label for that embedding type. Within there. So we're using these to help kind of control and drive how we or what we vectorize within our solution, and then also how or what it gets stored within our cognitive search. Okay, next I want to open up our durable prompt service. So here within this service here, so what this service does is this is used to retrieve the system prompts that are stored that I showed you earlier as text files from blob storage. So these are both going to be skills within semantic kernel, and of course those text files provide instructions on how to behave and perform tasks. And of course we'll see those when we go and step through these. Okay. Next, I want to go and open up the semantic kernel RAG service. So this is the entry point for the chat service web API, or sorry, for through the web chat service web API, but it's a service layer that interfaces with the underlying semantic kernel and helps tie all of the major components together. So here, let's go into the constructor for this here. So when we're going and creating a new instance of our semantic kernel RAG service within our builder here, we are going to have a new Azure Text Embedding Generation service here, and then of course we'll pass in, this is the name of the embeddings deployment model that we've got, so this would be the embeddings text ADA002, and then of course the endpoint and the key for our Azure OpenAI service. Same for the chat completion service. This is going to be the GPT-3.5 Turbo within here. We are also going to define long-term and short-term memory objects within here. So we have our Azure Cognitive Search vector memory implementation within here, and this, you can see, will have an endpoint, a key, and also the index name for that within there. We also pass into the constructor for this object the text embedding generation. So this is functionally, we are passing in Azure OpenAI embedding generator because when we add new data to our Azure Cognitive Search vector memory, we of course want to vectorize that data. So it makes sense to pass a reference to that when we instantiate that service. And then last is our short-term volatile memory store. We talked a little bit about this earlier, but this is the data that we get at runtime when we go and start the service. That will go and run some faceted queries over our product catalog data to count up all the products for each category, and then of course all the products for the entire service. Okay, let's go a little further down here. So let's talk a little about get response. This is really kind of the main function for this entire class. In fact, it's really kind of the main function for the entire solution. This is what executes the query and then generates the completion from OpenAI and then returns the results. So one of the things I want to point out is we limit the number of memories here to just the top 10 with the top 10 that come back from cognitive search. So here you can see from the settings here we have this max vector search results, and this is important because we can't return everything back and then send that to Azure OpenAI. In fact, you're going to find there are lots of things that we need to do to try to optimize and minimize the amount or size of the payloads we use here, because all of these things are governed by the number of tokens that they can use in a single request. So after the query returns here from the recall async within here, the next thing is we are going to build what we've called a new chat builder object in here. And this is implemented in semantic kernel. And what this does is this builds the payload for what semantic kernel will send to Azure OpenAI to generate the chat completion. And so this includes pretty much everything we are going to need. So we are going to have a reference to our semantic kernel. We are going to have the maximum number of tokens that we can have for that entire response, or that can be used to generate the response. We are going to have configuration values that we're going to use for all the token management within there. We are going to launch or also include things like the system prompt within here. We want to send that. Of course, that's going to be part of that payload within here. We are going to send all of the memories. That is going to be the conversation that is going to be part of that. Or sorry, not the memories, but the message history. That is going to be part of also what is passed in to generate the response. So the code here basically takes everything and the text return from OpenAI with all of the tokens and sends this into the function to go ahead and then be generated. So I'll go a little bit more into this in just a moment when we get into it. But first, I want to move into our semantic kernel project here. So first thing I want to do is I want to go and open this up and then look at the Azure Cognitive Search folder. So there's two things we want to look at in here. And first, is the memory type we create with Azure Cognitive Search. And this is what we created before when we had the connector for it. So now this is just a little bit easier with using the plugin we'll have for this. But here we've essentially just created this by hand because at the time we wrote this, we didn't have plugins or anything else that handled any of the vector search that's within here. Next, I want to go into the chat folder here. And like I was showing earlier, the key thing I want to show here is the chat builder. And this is a key component of the entire solution because this is how these completions get generated. And a lot of important stuff happens in here, including kind of the optimization for the prompts that are within here. So we'll go a little bit more into that in just a second. But this is, again, a very key thing that's happening within here. Let's go into next. Okay, next let's go into the skills folder within here. And there's a couple things I want to show you in here. First, we have this generic summarizer skill. So this is a semantic function that is used to essentially provide that summarization that we're looking for after there's a few messages within there. So this defines the function that gets called against semantic kernel to go and then generate that summary that's within our memories or within the messages that are within there. Next, this is the text embedding. This is the object memory skill within here. And then this defines how memories are retrieved from within the semantic kernel. And there are two types. There is the long-term memory. This is data that is stored within the Azure Cognitive Search. And then, of course, the short-term memory here. So when we call recall async here, this provides the semantic function, the semantic kernel function that helps pull that data together when we call the recall function here when customers are typing in some prompt within there and then calling into semantic kernel. Okay, I want to go back to our chat builder here and talk about token management. So one aspect to building these RAG pattern solutions, and it's a key aspect, is managing the tokens that are used in the request to OpenAI. Requests need to be within the maximum allowed for a model. Now the payloads for these requests can be rather large because you're querying for additional data. And that data can grow beyond what a model may be able to handle. And if you pass enough data that it consumes all of the tokens in that request, you're likely going to get an exception out of the service. However, it's not enough just to remain under the maximum amount. You also need to leave enough tokens for the completion. Not enough, and the response that you get may be incomplete. In fact, it may just stop mid-sentence. And in this solution, we spent a fair amount of time and wanted to highlight to you here on implementing a way to measure token usage for the request and then also ensure that we leave enough for the response here or the completion. So to do that, we have our function here. This is optimized prompt size. And this is where token management is handled within our chat builder class. Now, at the time of this recording, this method uses the semantic kernel tokenizer. And this wraps basically the open source GPT-3 tokenizer within there. And this tokenizer takes text and generates an array of vectors. The number of elements in that array represent the number of tokens that are going to be consumed. It can also do the reverse and take an array of vectors and output the text. And this is especially useful because we can essentially equate everything in tokens and adjust numerically to get the payloads just right. One thing I should point out is with the version 1 for the semantic kernel, they have removed the tokenizer out of there. So we are going to be implementing a different tokenizer that we'll use for this solution here. So the code you see in here, or at least the tokenizer, if you look at an earlier version here, will be different in November when we do a major update to this solution. Okay, so let's scroll down here and I'll kind of walk you through. So when this function gets called in the build function for our chat builder, we do a few things. First, we need to get a tokens or the number of tokens for the system prompt. So we pass in a string for the system prompt and then return back an int, which is the number of system tokens for that. Next, we want to take all the memories for this, and then we also want to tokenize that. We'll also normalize the line endings in there just to keep things trimmed down. So for each of those within there, we are going to go and call the get tokens count using our tokenizer object and then save those. We'll also do the same for the messages that we have. So this is the conversational history that we have for our application. We're also going to put this in a reverse order. And the reason is when we go back and reduce the size of that list, we only want to keep the most recent messages that we have in our conversation. That, of course, we want to keep the most recent messages within there versus the older ones because they're going to be more contextually relevant to the response that gets generated. So this is for this reason we go and reverse the list. And you'll see further down as if we have to reduce that, it's going to pop them or take them off the top, which is the oldest messages within that conversation versus the newer ones. So here we've gone and we've tokenized everything within here. So what we're going to do is we're going to count all the total tokens. So we'll count up our system tokens. We're going to sum up all the memories and the tokens within there. We will sum up all of the messages, and then we will add a bit of a buffer for tokens. I think we've got default is at 50 tokens within there, just to add a little bit of buffer within there. So we compare the two. If we're less than or equal to the max prompt tokens that we define or within our configuration, then we're good to go and we just kick out. However, if they do not fit, then we start trimming down things and we go a little bit each time until we get things to fit. So the first thing we do here is we go and we measure whether or not our system tokens are at or less than the max tokens that we've defined, and if they're not, we just throw an exception right away in there for you. Next, we go and we limit the memories that come back within here. So, and this is part of the RAG payload or the vector query payload within here. So, go and for each of the memories that within there, we'll just go and start and break that down. And then next, let's go ahead and then we'll do that for the messages. So we'll go through the messages in here and go through the max tokens within there. And return that down, and then just keep going. We'll take one more sum of this here, so we'll measure the memory tokens, the message tokens, and then all of them again, and then see if we're good. And if we're not good, we just continue to knock things down. So here we are going to go and remove memories within here until we get below that token count. Do another pass in here. Still not good. We're going to take messages out of here and start trimming those down as well. And then just keep going until we get to the very end. And of course, at some point, if you're just too big, we just throw an exception and we're not able to go any further. But usually we'll never get all the way to the end here. These usually will fit earlier on, and this function will exit much earlier than going to the end here. So you shouldn't really ever need to worry about getting to the point where you are not sending enough information. Conversations may get a bit long in here. That may be something you may want to look at in terms of if you're throwing an exception to go back to the user and say, hey, this is too long. But typically you should be able to handle this by just configuring the max number of tokens for things like memories and things like the message size in here. But this is an important section, and I wanted to walk you through each of these stages within here, just simply because this is going to be something you're going to want to keep an eye on. So a major component and hopefully this will be useful to you as you walk through or as you build your own application. Okay, next we're going to start up our application here, and we are going to step through the entire workflow or request flow for a RAG pattern query. So a user prompt, vector query, completion generation, and then response to the user. So let's go ahead and then we'll walk through that. Okay, we've got our application opened up here, and we'll go back to conversation we have here on product categories here. We had a question here, can you list some of your road bikes? And it gave us a long list of road bikes here. Let's just ask it a follow-up question or another question. Can you list your mountain bikes? So we'll go ahead and press enter here. And you can see we've gone all the way past from our web application, and we are now in our vector search and AI assistant service in the chat service here. So I'll show you within here, we are in this service here, the chat service. And this is the function I showed you earlier when we first came in. This is basically the entry point from the front end into the service layer here. And the first thing it is going to do, it is going to go and call the Cosmos DB service and retrieve all of the conversation for this this chat that we've got. So let's go ahead and we'll just F10 through that, and we should have a list of messages that come back in here, and you can see all of these different messages. We have a user, an assistant. You can see the tokens within here as well. Next, we're going to go and we're going to call the getResponse function. This is against our RAG service within here. So this is going to call this semantic kernel RAG service. And that's going to pass in the user prompt. And you can see that here. Can you list your mountain bikes? As well as an array of all the messages. So let's go ahead and we are going to step into this function here. And here you can see we are in our semantic kernel RAG service here at the top. And we'll just walk through some of this here. So we are going to go and create a new memory skill object here. And then the first thing we will do is then we were going to call this recall async against our memory skill. So this will pass in our user prompt and then the index name from earlier. And then also we are going to specify the max number of results that are going to come back. So let's just walk into our skill here. Oh, I don't want to, yeah, I want to be notified. Okay, so walking into our skill here, let's just step through some stuff here. And here we're going to search our memory. So this is a wait on the long-term memory. Search async. This is going against our collection within Azure Cognitive Search. So we'll go ahead and let's just step over that. And here we are going to go and then keep going here, and then short-term memory here, and we do have some short-term memories that are defined within here. So we will go ahead and pull those in and then do a select out of those as well. And then we will go ahead and then concatenate and combine those together into our list. And here you can see we have combined memories in there. And let's go ahead and return that in there. And then just keep going here. And now we are going to go and we are going to create our new chat builder object. And this is the one I talked about earlier, where kind of the entry point for when we do a whole lot of work around all of our prompt optimization. So let's go ahead and then we will step into this. Yes, just go ahead. In here, creating a new chat builder class. So we're in the constructor for that here. And here you can see these are all of the configuration values. These are all defaults within here that we have, but we read all of these out of our configuration values. These are all stored within the environment variables within our service container in there. So you can see we've got more max tokens within here. So keep going. Yes. Now it's going to go and get our system prompt. So here's our prompt name, the retail assistant.default within here. So this is going to go and grab that out of our blog client, and then we'll read that. And here you can see you're an intelligent assistant for the Cosmic Works Spice Company, just everything we showed you there earlier. Okay. Now we are in our optimized prompt size function here. So let's go ahead and we're going to start counting up the system prompts. And here you can see we call the tokenizer for our system prompt that was in there, and that's taking 131 tokens. Next, we're going to grab the tokens for all of our memories. So this is the data that gets returned from Azure Cognitive Search, as well as the short-term memories we've got within there. And you can see for these in here, you've got the memories, and then you have the tokens for each of them within there as well. So you can go through the whole array of different memories and their tokens. We'll do the same thing for the messages within here. So we'll go ahead and just run through those, and you can see for the messages, we've got 8. These are all of the messages that you have going all the way back to the very beginning. What kind of products do you sell within there? Of course, we're putting that in reverse order as well. Next, we want to take and add up all of these tokens. So let's go ahead and we'll just add those up. And you can see we've got 2,390 tokens in here. We need to be beneath 7,746. So we are good. At this point, we can go ahead and return since we're beneath that amount within there. So that we'll call the optimized prompt size. We've got an optimized prompt structure that we're going to send in. We're going to create a new chat within here. Here we go. We have our memories within there, and we are just going to start to build this out. Go through each of the messages that are within here. And we'll just go ahead and run all the way through to this. Yep, and then we'll add our user prompt at the very end there. And then we're going to get the chat service, completion service from semantic kernel within here. And then we are going to call get chat completion async, and that is going to pass everything in to our service there. Sorry. And there you go. Here is then the reply. It's going to come back from that. Here you can see there's the completions and the semantic kernel. Is it going to show me this? I think I just have to go and just go into this here. And you can see from here, if I go in, and here you can see here's the content from here. Here's all the mountain bikes that are coming back as well from within here. Right, and then go ahead and just keep going, and then we will return all of these values in here. So here's the content from the response, and then here are the prompt tokens. Here is the completion tokens. Here is the user prompt embedding as well, and then we'll go ahead and just return that. And then that comes back, and of course we're going to parse all this out. We're going to create new messages for these things. So we have the message for the prompt and the message for the completion, and then the completion prompt, and then we're going to set a completion prompt ID value on there. Whoops. Yeah. And then we'll go and show you this. This is going to go and go into our chat service, get the chat session here. We're going to go ahead and update. This is a local cache version of that we store within the service, and then we are going to go ahead and add the tokens used from the prompt, the tokens used from the completion, so that now has more tokens for the entire session. And then we're going to pass in the prompt message, completion prompt with the session, and then we are going to do a transactional batch on that here. So pass all those in, they just get passed in as a dynamic array. We'll go ahead and grab the session ID out of there. Everything within the transactional batch needs to be scoped to the same partition key, and in that case that is the session ID here. So we'll go ahead and create the new partition key value. That's the session ID within our object, and then we're just going to iterate through all of the items within here, and then we're going to call batch upsert on it with the item in there. And then after we pass all 4 of those, we will then call the batch execute async. That executes the transactional batch and then returns back. And then here you can see here is the response, and we'll just let this go all the way. And here you can see here is our new response. There we go. From all of our mountain bikes back from the Azure OpenAI service. So here you can see everything that comes back. And so that's kind of the whole flow for what happens from a user prompt all the way through the service and then back again. So there's one last thing I want to show you, which is to walk through adding a product into the service here. So I showed you this in the runtime, in the deployment, the production deployment we had for this. I would like to step through what happens when you add a new product and see how that gets picked up by Cosmos and then inserted, vectorized, and then inserted into Azure Cognitive Search. Okay, so first thing I'm going to do is let's go and find our change feed function within here. I have a breakpoint set in here, and this is our change feed generic handler. So this is configured to monitor the product container as well as the customer container. So we are going to add our product. We're going to add our Cosmic Sock back into our container. I took it out a bit earlier. And then we will watch this work. So here's my Cosmic Racing Sock again. And here I'm going to add this, and I'm going against a local endpoint. So this is localhost on 63.279 port here against products. So let's go ahead and I'm going to send this. And here you go. It's already in our change feed handler. So what we're going to do is let's walk in. I'll show you the model registry here. So this is going to take this object that you see here. So here is, oh, it's not going to show me the JSON viewer, but that's okay. So we'll just go into here, and then this will go and figure out the product type within here. And you can see this should be a product within here. Where are you? Oh, I'm not finding it. The wrong one. Let's just keep going. Oh, going through all the properties within here. Sorry, you can see description, price, tags, vector in there. And so that's what we'll keep going against the model registry here. Yep, and here you go. Yeah, let's just step out. Here we go. Okay. So here, the type from here, and here you can see the type is the product within here from the model registry. And it pulled up the information that I showed earlier from within here when it looks at the model registry, it is going and looking at saying, okay, you're a type of product. So the matching properties we're going to use is going to be SKU, and then the naming properties we will use are the name. Okay, so next, let's go, and you can see the entity type here. We are now going to add the memory to the RAG service here. So let's just go and walk through this and get the property values out of that. And here we are going to add the memory within here. So here you can see the item name is Cosmic Racing Socks. Here is the entire object within here that you can see. And then we're going to call, on the long-term memory object, we're going to call add memory. Let's walk into that. Here, this is going to call the embedding utility to prepare this for being transformed in here, and I'll walk through this and you can see here is the vectorized data for that right here. So this takes all of the takes the object itself and then generates the vector on that data, and then from the search client calls index document async and then calls an upload on the item that you see right here, including its new vector that's added within here. Okay, so we'll just go ahead and run that all the way through. We're back, and then back into our user interface here. We'll go ahead and create our new chat. We'll just say, go ahead and list all of your socks, and it's going to set a breakpoint and probably hit a few of these here, so let's let these go and just run all the way through. And here you can see, so here's our Cosmic Racing Socks are now appearing within our product category or product catalog here after doing the add in there. So of course, just like we can add a product within here, we can also delete a product as well. So if we wanted to go and delete a product, we could just pull this one up. This is also going against our local debug endpoint, and I'm just passing in the product ID and then the category for that, and I'll just pass that. And that goes right to that there, and then that should be gone. Let's ask it again. Can you list all of your socks again? This may come back and show the same data. We can kind of ask it to, yes. Let's ask it. Can you please double check from the JSON data you have? Let's see if we can force it to look at its query here. Okay, so it is confused. Let's ask it again. Please double check. Now it is getting confused because of the JSON data. Well, let's just go and we'll start a new chat. That always seems to fix your socks. And here you can go. We're back to our 4 socks again within here. So this can happen because the conversation is part of the payload that gets sent to Azure OpenAI. And so it can look at both the prompt data that's within there. Well, it's not using that here, but it can look at both the prompt data as or the user prompt messages, as well as the memories that get pulled out of both the Azure Cognitive Search as well as any short-term memories. And then that all gets passed as a payload, and then Azure OpenAI generates the response. So, okay, well, let's go back to our deck and we'll close out here. Okay, we're back. So that's pretty much it, or it is really it. Complete run through from front to back, deep dive on the source code for our solution accelerator for building modern AI applications using Cosmos DB with Azure Cognitive Search, Azure Container Apps, built-in .NET, using semantic kernel with, of course, Azure OpenAI. Just some additional resources for you. Of course, the solution repository for this on GitHub, github.com/Azure build-modern-AI-apps. Also links for Azure OpenAI, just getting started for that. We also have a page on vector search and Cosmos DB. There are multiple options for doing vector search or for building Azure or AI apps using Cosmos. You can use our Cosmos NoSQL in combination with Azure Cognitive Search, particularly if you're trying to do vector search over multi-model data. Our solution includes things like files, like there are product policies, shipping policies, return policies. There's other kinds of data you can bring in and make that part of a solution. In a real e-commerce app, you may have things like product images. You are going to have other types of files and other types of data, not just data within a transactional data store. So combining those with a transactional data store like Cosmos DB can provide a really great way of building transactional operational applications like a retail setting, or could be anything where you've got real-time or near real-time data and you want to bring that together as part of an AI solution. Also, semantic kernel. Semantic kernel is a key part of this solution and how it all works together and how it all gets orchestrated. So definitely recommend going and reading up on semantic kernel. There are lots of samples and how you use semantic kernel to build these types of Copilot applications. You can go back to the GitHub repository at the top there and go and take a look at the Project Miyagi work in there and get a lot of other examples on how you can build these types of applications and how you could use things like semantic kernel to build them. Last, all of this is hosted on Azure Container Apps. So there is a link there. You can go and learn about ACA. You can also run this solution on Azure Kubernetes Service as well. So there's information as well. You can go and learn about that. That is it for our solution. I want to thank you for spending the last hour and 30 minutes walking through this solution. I hope this provides you a lot of depth on it. We will provide and build, I'm sure, more videos on the solution. The solution itself will be continuously updated to include updated packages, also new features, and other changes and fixes and other things. So please keep an eye on our repository. Feel free to ask questions in the issues list. And that's it. Thank you very much, and I hope you enjoyed this session. Thank you.